Hello! Today we're going to solve more real-world word problems involving exponential growth, exponential decay, and how do we do interest for like bank accounts and money and stuff. So remember your exponential formula, the basic general one is y equals a times b to the x. You have two types of exponential situations, a growth and a decay. So if it was a growth formula, remember that it was 1 plus our rate. If it's a decay, it was 1 minus our rate. And that your A value is what you're starting with. Your rate, don't forget, has to be written as a decimal. If it's given as a percent, you have to write it as a decimal. T is your time and Y is your ending amount. Those two formulas are more of a review because I covered them in the first video. Interest formulas. We are dealing with money, okay? I want to put $500 in the bank and I have a 2.3% interest rate. Am I going to get that interest rate every month, every week, once a year, quarterly? Okay, so this is the formula that we're going to use. It looks almost identical to the growth formula and decay formula, as in you have the 1 plus r. This is your starting value, right? This is what you're ending with, but there's this n here. That is needed because let's say you get your percent, your interest rate, quarterly. That's 4 times a year. So then I need to take that rate and divide it by 4. And then I need to take my time and multiply it by 4. I'm getting it 4 times out of a year. Okay? So if you're yearly, or if it says annually, n is 1. Quarterly, 4 times a year. Monthly, obviously there's 12 months in a year. And weekly is 52. Okay, looking at example 1. We have a new car and it costs $23,000. As soon as you drive that car off the lot, it depreciates. It goes down in value. Okay? And new cars decrease by a lot in those first couple of years. So this car decreases by 15% each year. Can you write me an exponential function for this? I don't know what I'm ending with, but I know my new car costs $23,000 to start with. I know the value decreases, so that's a 1 minus situation, and it decreases by 15%. 15% written as a decimal is 0.15. And if it's each year, I just have t. Time is every year. Okay? So if I take 1 minus 0.15, my equation will be 23,000 times 0.85 to the t, or x if you would like to use x. Use your model then to tell me how much is the car after 3 years. I know the car started with 23,000. It went down by 15%, so 0.85 to the 3 for 3 years. Going to our calculator, 23,000 times 0.85 to the third. Gives me the car is now worth, only after 3 years, $14,124.88. Okay. Example 2. Between 1992 and 2000, the value of a comic book has decreased by about 4% each year. In 1992, when it first came out, it was worth $135.50. What's the value of the book? Sorry. In 2000. Okay. So I'm trying to figure out my ending amount. I don't have that because I don't know how much it was in the year 2000, but I know it started with $135.50. I know it decreased, so I have a 1 minus situation, and it decreased about 4%. 4% written as a decimal is 0.04. Move it over 2 spaces. And I don't know my time. So I have $135.50. 1 minus 0.04 is 0.96 to the t. If I want to know the value of the comic book in 2000, and I first got it in 1992, it has been 8 years. So my time is 8. Evaluating 135.5 times 0.96 to the 8 gives me 135.5, 0.96 to the 8 tells me the comic book is worth $97.75 today. And that's true of a lot of things, right? As soon as you get it, it decreases. If I go out and buy a brand new cell phone and I try and trade it in a year or two later, they're only going to give me like $50 for it. True story. Okay, let's try another one. Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that can be used to model this. So, how much did she start with? She started with 7,500. I know 4 hours is my time. And there are 23,000 cells after 4 hours, so that's how much I end with. In this problem at all, did it tell you what the rate was? Nope. So, if I know an exponential function is a times b to the x, I know I'm ending with 23,000. I started with 7,500. I don't know what the rate is, but I know after 4 years, or after 4 hours, I had the 23,000. I know my time. We have to find what the base is. What would be the rate? To do this, we would first have to divide everything by 7,500. So 23,000 divided by 7,500 gives me 3.07 equals b to the 4th power. Now, earlier this year, I taught you how to get rid of an exponent like this. If it's written as 4 over 1, I could flip it and do 1/4. So I need to take my 3.07 and raise it to the 1/4 power, and it would tell me my base would be 1.32. So then writing an exponential function, I started with 7,500. I know my base was 1.32, and I don't know my time. I don't know how long I'm sitting in the lab looking at these cells. But I asked you for part B, how many cells can be expected in the sample after 12 hours? You've sat there all day, you've watched these cells grow and grow and grow. Then I could say I started with 7,500. I know my rate, my base, is 1.32, and I want to know how many is in there after 12 hours. So 7,500 times 1.32 to the 12. 209,869.07 cells. So after 12 hours, look how quickly that bacteria has grown. Now I know it's microscopic, but think of a disease running that quick. All right, example 4 says you deposit $1,500 in an account. You're going to get 4.2% interest from the bank. Find the balance after 3 years if the interest is compounded. Let's do it annually, monthly, and weekly and see what the difference is. This is the formula, A equals P, 1 plus R over N to the NT. So if I'm going to get my 4.2% annually, that means once a year. So that means N is 1. I don't know what I'm ending with, but I know I'm starting with $1,500. I know my rate is 4.2%, and as a decimal is 0.042. If I'm going to get it once a year, n is 1, and I want to find the balance after 3 years. So n is 1 times 3. So I type this in my calculator. 1,500, 1 plus 0.042 divided by 1 to the 3 times 1 is 3. So after 3 years, if I start with $1,500, I now have $1,697.05 in the account if I just let my money sit there and grow. So what happens if I take the same amount, I get the same interest rate, and instead of getting my 4.2% added to my account once a year, let's say I get it monthly. So now my n is 12. Every month, whatever's in my account, they're going to give me 4.2% added onto it. So I'm still starting with 1,500. My rate is still 0.042, but now I'm going to get that every month. So 12 months in a year times 3 years, because I want to know my balance after 3 years. Typing in this, 1 plus 0.042 divided by 12 months to the 12 months times 3 years. Now I have $1,701.05. So I have a little bit more money if I get my interest rate every month. What happens if I get my 4.2% at the end of every week? Well, there's 52 weeks in a year. I have $1,500. I'm getting 4.2% over 52 weeks times 3 years. Typing this in, 1,500, 1 plus 0.042 divided by 52 to the 52 weeks times 3 years. Now I have $1,701.34. So not a big change to go from monthly to weekly, but still more money than what I had, okay? So when you go to a bank and you say, I want to open a savings account or a certificate of deposit, a CD, or a money market account, they have promotions to where like, oh, I want this CD and you're going to get it every 7 months or every, 6 months or, okay? So make sure you check that. The bigger the percentage and the more times you get it, you're obviously going to make more money. Let's try another one. You want to invest some money into an account. They're going to give you an 11.5% interest rate because you want to save for a new car. You want to buy the car in 5 years and you have to have $18,000 saved by then. How much money do you need to put into the account originally to have $18,000 at the end of 5 years? So the $18,000 is how much I want to end with. 5 years is my time. I have a 5-year plan. I want to have this much money at the end of 5 years. I know that I'm going to get 11.5% as my rate is 0.115. I don't know how much I start with though. So out of this formula, I am looking for my P. I'm ending with $18,000. I don't know how much to start with, but I know I have 11.5%. Since it's annually, that's once a year, you're going to get 11.5%. And I want to know how much I have after 5 years. So, to solve this for my original amount, this is P times a number. If I take that 1 plus 0.115 divided by 1 to the 1 times 5, that's just a number, about 1.723. Right? So then to solve for P, I would just have to divide by that. I need to take $18,000 and divide it by my rate. If I do that, I would have to put into my account about $10,000, a little over $10,000 to end up with $18,000 at the end of 5 years. So my original amount was $10,444.75. If I had $10,000 right now to put into an account, I'm getting 11.5% interest rate. At the end of 5 years, I should have $18,000. That's how quickly it's going to grow. Okay? So that's the end of our exponentials. We will review and then we will test probably next week. All right, guys, I'll see you later. Bye.